Welcome, 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 welcome to Science and Engineering World, where we enjoy doing mathematics, much more mathematics. In this presentation, I want to use a practical scenario to demonstrate the properties of rats and other triangles. My name is Olutola Fakehinde. I designed this to demonstrate the use of triangles. The scenario says that a mother from an apartment on top of a building observes her son ride his bicycle home from college on a straight road leading to the building at an angle of depression 30 degrees. By the time he rides 400 meters towards the building, her angle of depression is now 60 degrees. Question: how far is the sun to the base of the building? And 2 is, what is the height of the building? Before we move on, I would like to encourage everyone watching this video to please subscribe to this channel. This will enable us to be able to do more of the videos, and then for YouTube to push this to other viewers in the world. And I appreciate you for doing so. Now to this problem. We have a schematic diagram that shows this, the mother sitting at this top of the building, observing his boy riding home, and her angle of depression was 30 degrees. And later on, after the boy has moved further to the building, her angle of depression was 60 degrees. The question asks, number 1, that what is the height of the building, and number 2, how far is the boy to the building at the last observation. At the first place, when the mother was looking at the boy, he has an angle of 30 degrees of depression. So that angle 30 degrees is also equal to this angle here, 30 degrees, because of alternate angle. That is, angle B is alternate to angle C. Similarly, looking at the angle of depression 60 degrees, it means this is also alternate to that angle. So this will be 60 degrees. Now, all the angles on a straight line are always 180 degrees. So in that case, if this is 60, then it means the obtuse angle D will be 120. Good. So with this, we can start looking at how to solve the problem. First, let us look at the right angle triangle ABD. So in the right angle triangle ABD, we now know that we have the height AB is H. So this is H, and then this is X, and this is 60. So we can now put these 3 dimensions together as saying that tan 60 is equal to opposite H over adjacent X, where we can say that H is equal to x tan 60 degrees. From the previous video, which I will put the link above, we know that tan 60 is root of 3 over 1. So we can now say that h is equal to x square root of 3. So let's call this expression 1. That is, h equals to x square root of 3. In the obtuse triangle, we have BCD, where C is 30 degrees, like we have seen before. This is 30 degrees. And then D, which is the obtuse angle there, is 120. The sum of the angles of a triangle is 180. So if D is 120 and C is 30, that the two of them will be 150. And we take it away from 180, it means this angle here is also 30 degrees. Now we have DC is 400, and let's call BC Y. Trying to find Y. Now we are going to apply sine formula here. Sine formula says Y over the angle that is facing Y is sine 120 degrees. Will be equal to 400 over the line that is the angle that is facing 400 is 30 degrees. So sine 30 degrees. Now we can put them. Now we can find Y. Say Y equals to 400 multiplied by sine 120 all over sine 30. Sine 120 is the same as sine 60. In another video, I showed the link between angles that are greater than 90 degrees. So in this case, we can now say that Y is equal to 400 times sine of 60 over sine of 30. Again, we know that sine 60 degrees is equal to sine 60 degrees equals to root of 3 over 2, and sine 30 degrees equals to sine 30 degrees equals to 1 over 2. So if you put this together, we can now see that Y equals to 400 times square root of 3 over 2. Now if we are change this division to multiplication, then we are going to invert the denominator. So we're going to say that times 2 over 1, which gives us 400 times the square root of 3, because 2, we take 2 here. So we now say y equals to 400 square root of 3. So let's call this expression 2. With the big right-angled triangle, we now know that this is y, which is the big hypotenuse, and we can say from Pythagoras theorem that y squared will be equal to h squared plus x plus 400 square. Now h is x square root of 3 and y is 400 square root of 3. So let's put these two inside this. So we can now write 400 square root of 3 bracket square equal to h is x plus x square root of 3 bracket square plus x plus 400 bracket square. And from here we can see that we have an equation with just x unknown, and let us see, by the time we expand the brackets, let's see what we get. In this case 400 square root of 3 or bracket will give us 400 squared, as 400 squared multiplied by root of 3 squared, square root of 3 squared, to be equal to x squared square root of 3 squared plus, now let us expand this one this way. This will give us x plus 400 bracket x plus 400 bracket. This x will multiply this x, and it is also multiply this 400, and this 400 will multiply this x, and it will also multiply this 400. So we now have x squared plus, that's x times x squared, x times 400 plus 400x, then 400 times x, that will give us 400x, plus 400 times 400 will give us 160,000. 60,000. So we transfer this into there to give us x squared plus 400 plus 400, that is 800x, then plus 160,000. Alright, let's try and make it very neat. Now we have 400 squared at this side, that will give us 160,000 square root of 3 times square root of 3 will give us 3, and this will be equal to x squared square root of 3 times square root of 3 will give us 3, plus x squared plus 800 x plus 160,000. Good. Again, let's make it neater again. 160,000 times 3 will give us 480,000. Will be equal to 3x squared plus 1x squared will give us 4x squared plus 800x plus 160,000. Making it neater again, we can move this across, and then we can now write 4x squared plus 800x plus 160,000 minus 480,000. This will now give us 4x squared plus 800x. Now 160,000 minus 480,000 will give us minus 320,000. 20,000 will be equal to 0. So this is a simple quadratic equation. Dividing everything by 4, we now have 4x squared over 4 plus 800x over 4 minus 320,000 over 4 equals to 0 over 4. This will now give us x squared. 4 we divide 4 to give us 1. 4 dividing 800 will give us 200 plus 200 x, and then 4 dividing 32 give us 8, then 0,000 to give us 0. If we look closely, we can see we should be able to factorize this, because we have 1 times 80,000, and 80,000 will give us 80,000 can be written as 200 times 400. That will give us 80,000. Okay, let us see here. If I take 200 from 400, I'm going to get 200, which is what is going to give me this. So I can now factorize and say that x squared minus 200 x plus 400 x minus 80,000 will be equal to 0. Now we can combine these two and these two. So we now have x into x minus 200 plus 400 into x minus 200 will give me 0. And that's because these two brackets are the same, so we can write x plus 400 and then we take one of the brackets, so give me x minus 200 equals to 0. So what are we saying here? We are saying that x plus 400 must be equal to 0, or x minus 200 must be equal to 0. Now we have x equals to minus 400 or x equals to 200 plus 200. Now the length cannot be minus, so we're going to take x equals to 200. So we can now say that our x equals to 200. So equals, that is the distance from the second observation to the building is 200 meters. Okay, so we now put that in. This is what we use to factorize, so we can bracket that. So we now put this into the fact that h, where before h equals to 200, that's x square root of 3. We then say that h equals to 200 square root of 3. Square root of 3 is square root of 3 is 1.732. That will give us 2 times 173.2, and we can now say that h equals to 4.6, 4 remaining 1, and that's 3. So in essence, up to nearest meter, we can now say that h equals to 346 meters. That is 200 meters. And this height will be 346 meters. If you enjoy this demonstration and find the video very useful, give it a thumb up, share with others, make comments, because like I always say, there are other methods of solving problems like this, especially this particular one. There are other methods of solving it. So let us know your method in the comment section below. Then share, subscribe so that this video can continue to go viral to the other parts of the world. And like I always say, keep having fun and at the same time keep studying.